Hello students, welcome to the next lecture on the real analysis. Today I will explain you how you can solve all those PY questions related to the topic sequences with the help of shortcut trick. Myself Dr. Harish Garg. You can simply follow my YouTube channel where you can find the playlist is named as IIT JAM solution, and you can see the various PY question series is available in this playlist. Apart from them, if you are from the GATE mathematics student, then you can again see there is a playlist of the GATE mathematics, and you can find the various lectures related to this PY question series. So let me firstly give you some shortcut tricks so that you can solve each question within the 10 to 15 second time period. So first of all, whenever the statement will ask you find the limit of the sequence, so make sure when you take as n approaches infinity, it must exist and unique. The uniqueness is one of the most important thing. For example, if I take this is my sequence, it has the 1 and minus 1 when n is my even and odd. So you can see there is the existence of this. If you take the limit as n approaches infinity, it exists, but it is not unique. So once it is not a unique, it means this is not convergent. If you will get more than one limit point, if you find the limit point of the sequence, if you get more than one limit point, then you can say the sequence is not convergent. That means you can say it's a divergent or oscillating. Every convergent sequence is bounded, but converse is not true. For example, this is the sequence. We all know this is my bounded, but it is not convergent. If you are working on the real lines, that is on the R, then a sequence is convergent if and only if it is Cauchy. So that's if and only if result only in the R, not in the other dimensions. Cauchy sequence is always bounded, and when you are talking about the real line, then Cauchy sequence is always convergent. Every sequence is a subsequence of itself, and if you prove that a sequence is convergent, then the subsequence is also convergent to the same limit. However, if you prove that the sequence is divergent, then every subsequence will also diverges to the same limit. On the other hand, if you prove that all the subsequences converges to the same limit, like if I say a of 2n, this is a subsequence of an, if it is convergent to the L1, then, and I consider the odd sequence L2, if L1 is equal to L2, then only you can say an converges to the same limit. Remember, the word is the same. Otherwise, if L1 is not equal to L2, it means they are convergence to the different limit, then the sequence is not convergent. And the last remark is every sequence has a monotonic subsequence. So that's a simple shortcut tricks I have given you. Now based on these tricks, I can solve each PY series. The last step is whenever you have to find the average of this, that's the sum divided by n, you always use the Cauchy first theorem, but make sure your sequence an is my positive term series. Similarly, when you have the positive series, then if you find the limit of ratio, then the power of this will also converges to the same limit. Now let's start with this first question. What is given to you? An are the sequences such that b of n is my a of 2n and c of n is my a of 2n plus 1. You can clearly say these both are my subsequences of, these are my subsequence of an. Now what is given to you? An is convergent. So what does it mean? If an converges to the L, what does it mean? A of 2n is also convergent to the L. A of 2n plus 1 also converges to the L of the same limit. Fine. Now if I take the limit of this, so what is the implies for that? Bn convergent to the L, Cn convergent to the L. If I take the limit as n approaches infinity, what does it mean? Bn and Cn both are my convergent. Fine. But he said need not convergent, Bn need not convergent, An is convergent implies Bn and Cn are convergent. And if you look for the last option, if Bn and Cn are convergent, then An is convergent. So what is the meaning of that? If I say Bn is convergent to say L1, Cn is convergent to the L2. So what does it mean? If Bn is convergent to the L1, it means a of 2n is convergent to the L1, a of 2n plus 1 is convergent to the L2. Now read the statement very carefully, whether it is given that it converges to the same limit. Is it given to you? No. They simply said it's a convergent. It means they are not always true. Once L1 is not equal to L2, then you can say the limit is not unique, then it is not convergent. Look at this another one. An is the sequence of this, and which of the sequence converges to here. Okay, firstly I can give you the simple tips for you. Whenever you will prove an plus 1 minus of an is k times cn, fine, and series cn is convergent. If you prove this term, that means this sequence is convergent. Fine, that's a simple tips for you. Now look at that. I can write the first term an plus 1 minus of an, which is equal to minus 1 over 2 raised to power n. So if I take the modulus an plus 1 minus of an, it will be, because this is a sequence, so it is my here. Fine. Now clearly say this is convergent. Why? Because it's a GP series, okay, and the common ratio is my half, which is less than 1. So that means an is sequence, an is convergent. Fine. So now it converges to the 0 or non-zero. That means our target is to find the limit of an. Fine. How you can find that? That's a simple, you can, because this is my series of Cn. So find, and what is the convergence is series of Cn. So what is the answer of this? It's a minus 1 of n of this. So it's a GP series. So A start from the 0 to infinity, sorry, n 1 to infinity. Fine, because n is my 1. So it will be my A over 1 minus R. Fine. So what is that? It's a minus half over 3 by 2. So you can clearly say it will be cancelled out. It is my 1 over 3, minus 1 over 3. So it converges to the 0, wrong option. It converges to the 0, wrong option. It converges to the non-zero number. Now whether the Bn is a convergent or not. So what you obtained, that An is my convergent. So if I say this is my L, L is minus 1 over 3. I can substitute here. So what is the limit of this as n approaches infinity? So if an converges to the L, we all know al plus 1 also converges to the L. So it will be my 2l minus L over L. It is 1. So 1, it is a 1. What is the meaning of that? Bn is my convergent, and on the real line convergent implies Cauchy. So that means Bn is my Cauchy sequence. Bn is not convergent is the wrong option. Look at this another one. Which of the following does not assures the convergence of the sequence? Very simple. This is, we already know that by the definition of this series, because you can see if the series is convergent, then by the nth partial sum sequence it is my convergent. So this is the correct statement, but we need a not a correct. The series is convergent. The series is convergent means the limit n approaches infinity, n of an will be 0. Now clearly say if it is infinity, then this is infinity into something. When it will be 0? Only when this will be my convergent. Fine, that means this value should be 0. So he said does not. So this is also a correct statement. A of 2n has a convergence. So I call this is my L1. A of 2n plus 1 is my L2. A of 3n is my L3. Remember, they are not talking about the same limit. So I can consider here. So now from here I can say it's a A2. A2 is convergent to the L1. From here, this is A. If I take n is 1, it is 3. 3 convergent to the L3. From here I can also obtain the A3. Fine. So from these two cases, what you obtained, L2 is equal to L3. Now it's a multiple of the 3. So A6 is also belongs to the L3, convergent to the A6 convergent to the L1. So from these two cases, I can say L1 is L3. So if all are convergent to the same limit, what does it mean? An convergent to the same L. So this is also the correct option. So the only incorrect option is A is my right answer. But can you provide me the example so that it will be the false? Very simple, the difference will be, so if I simply choose the sequence is log of n. So what is my this value? So n minus of n plus 1, fine. So it will be log of n over n plus 1. So clearly say as n approaches infinity, this value will be 0. So this condition satisfied, but we all know this sequence is my divergent sequence. So that's why the A is my wrong option. That's a correct answer of this problem. Okay, always remember, whenever you have a sequence, whenever you have of this nature, k varies from 1 to something of this, always try to write this into 1 over n form, 1 over n into something. So I can write firstly an 1 over n. So I can multiply the n and divide it by n on the both side. Fine. Now it is my summation, k varies from 1 to. Then your target is to find the sequence is convergent, divergent, means limit of an. This is your target. I can substitute the an, it will be my here. So that means I need to find this value. Then always consider I can divide it by n square on the both side. It's n square, it is n square. Then put k over n is my x. 1 over n dx, sorry, dk is my dx. So I can 1 over n is dx, it is my 1, it is a 1. So I can written k over n square as k over n into n. So k over n is my x over n. So what is the limit? When k is equal to 1, it's a 1 over n, and n approaches infinity is a 0. When n is equal to n, 1 is here. So what is the right answer of this? It's a log 1 plus divided by of here from 0 to 1. So it's a n log of 1 plus 1 over n, log 1 is a 0. So what is the right answer of this? N I can written the upside. So what is the limit of, this is my e. So log of e is my 1 is the, so 1 is a convergence because it's a unique, and the existence, so it's a convergent. It's a not convergent, divergent, divergent cancel out. So A is my right answer. Again you can see it's a limit and the summation. So I can write firstly in terms of the 1 over n. So I can return this is n square over n square plus kn. Fine. So I can return this number also 1 plus k over n. So I can take k over n is x, 1 over x, dk is my dx. So this value is will be 1 over 1 plus x into dx. What is the limit? Lower limit is 1. So 1 over n, as n approaches infinity, is a 0. Upper limit is n over n is my 1. So what is the answer of this? It will be my minus half plus 1 over minus half plus 1 from 0 to 1. So it is my root 2 over half. When you substitute 0, it is my here. So what is the right answer? 2 times root 2 minus 1. A is the correct answer of the problem. Okay, look at this one. The sequence is monotonic, bounded, convergent and here. So yn. What is my y1? It is x1 over 1. Fine. First of all, if you think about that, can you apply the Cauchy first theorem on this? No, because Cauchy first theorem is applicable only for the positive term series, but it is a negative also. Fine. If all are my positive, then you can simply prove if xn converges to the L, then the average of this will converges to the L, but it's a negative term also. So y1 is my here. What is my y2? x1 plus x2 over 2. What is the y3? Sum divided by 3 and so on. So I can define the yn like here. What will happen if n is my even? what will happen if n is my odd? If n is odd, it's a x1, that means this one. What is the x1 plus x2? 0. So if I take y4, clearly say the first 4 term 0. So whenever n is even, this answer is 0. Whenever n is odd, it's a x1, that's the first term. What is the y3? First 3 sum, that is a root 3, and so on. So it is written as only the odd term, that is a root 3, that's the third term, or I can simply say is the nth term. Fine? Or yes, it's a nth term only. So how you can think about this problem? It's a very simple again. So I can say now it has the even and odd. I can choose firstly for the even case y of 2n. So what is the limit of this is 0, because it has a 0. If I prove 2n plus 1 is also 0, it converges to the same limit, then it's a convergent. So what is the nth term of this? So y of 2n plus 1, 2n plus 1, x1, x2 up to the 2n plus 1. So clearly say the before term is x of 2n. So the first even term, the sum of the first even term will be cancelled out. What is the odd term? 2n plus 1. So what is the limit as n approaches infinity? 0. So both the limits have the same. So yes, this sequence is convergent. Fine. There is one more way. How? Always remember, basically I can repeat you, your target is to find this limit. Fine. How you can do? I can break them into the even and the odd component. Fine. If I take n is even, so y of 2n, that means limit n approaches infinity, n is my 2n, so this is x1 up to x of 2n. So what is the sum of the even terms? If you closely look about that, what is the sum of the even terms? Like 4, 0, 6, 0, 8, 0. So all the terms are my 0. Similarly, if you take as the odd terms, it will be my limit 2n plus 1. It is x1 plus x of 2n plus 1. So what is the odd term series? You can see the first 3 odd term, only the last term. So what is that? It is root of 2n plus 1 over 2n plus 1. So clearly say this value will goes to the 0 as n approaches infinity. Now both the odd and the even limits, there is a subsequence has the same limit. So yes, this is a convergent sequence. Fine. So it's not a convergent, not a bounded. Why not? It's a bounded sequence. Clearly say it's a lies between here. So so the only D is my correct answer of the problem. Okay. Always remember the tips. Whenever you have this form, product and varies from something to something, 1 to infinity or 1 to finite. So this is convergent if and only if summation of an is convergent. Fine. Make sure this an should lies between 0 and 1. Firstly, we will see whether it's a convergent or not. Although in this question they are not asking. So firstly, I can return this number is in the form of here. The lower limit is start from the 2 to n. So what is my an? It is 1 over n square. So can you find this series? It is 1 over n square, which is convergent by p test. Fine. So what does it mean? This is my convergent. Fine. So although they are not asking you about the convergent. Now second tips. What is the limit of this? Because once is a convergent, so it means it has a unique limit. So how you can find the limit of the unique limit is, it will be an. If it is a whatever the power of this, it will be power of this one. Okay, at the starting point. This is my shortcut tips for you. So what is the an is 1 over n square. Fine. What is the starting point is 2. So I can substitute value at here. So it will be 1 over 2 square, because the power is n square, power is 2. So it is my, so what is the right answer is 1 over 2 is my right answer of the problem. Look at this another one. Again I can return this is a product of 1 minus, I can return this is 2 over n into n plus 1. I can put whole square as here, fine, and your target is to find the limit. So firstly we can check about the what is the an. If I compare this by again this shortcut tricks, an will be 2 over n into n plus 1, and clearly say this value is lies between 0 and 1. Also this number is lies between 0 and 1. So what is the series? An, it will be 2 over n square plus n, which is a convergent by p test, because if you consider the bn is my 1 over n square, it is a convergent. Then your target is to find the limit. So 0, okay, okay, firstly I can, what is the limit of this? Fine, it's a whole square. Okay, what is the an is? This, fine. So what is the answer of this is 1 over starting point. Starting point is 3, so that means 2. So I can substitute an, n is my 2, so it will be 2 over 2, sorry, it's not a 1 over, it's a 2 over 2 into 2 plus 1, and it's a whole square, it is my this, fine. So it will be 1 over 3, that's my 1 over 9 is the right answer. And you can see also an, the starting point, because this is a non-linear, it's the term is 1 by n square, fine, but here the complete term is my single one, it is not be written in this complete form, so it's a 1 over 9 square. There is one more tips I can give you, it is a 1 over 9, fine. Another tips, what is that? If you given that an is my 0, if and only if this series is my divergent. So if you prove that instead of the convergent is a divergent, then the product of them is a 0, so the limit of them is also with a 0. But in this case it's a convergent, so that's why this option is cancelled. Okay, look at this another one. Xn is given to you as 2 raised to power 2n, 1 minus cos 1 over 2n. Then your target is to find the sequence convergent or not. Your target is to find the limit as n approaches infinity. So if you take the infinity, it will be the 0 into infinity form. So I can return this number is cos 2 raised to power minus n over 2 raised to power. So it will be 0 by 0 form. Now I can apply the L'Hopital rule. So it is 2 raised to power this into here into ln of 2 into minus 1 divided by the derivative of this 2 raised to power here into minus 2 into ln of 2. All of you know that what is the derivative of ax? It is a raised to power x ln of a or log of a. So this value will be cancelled out. Now sin x over x 1, it will be 1 over 2 raised to power n, it will be, no, this value will be cancelled out, then it's a 1 over sin x by x form. So it's a sin x over x form, fine. It is minus 1, it's a 1 over 2, so this value will be 1, so the answer is half is my, so it's a convergent to the half, because this limit is my unique, so that's why it's a convergent, and convergent is half is the right answer. Okay, what is the given statement is limit n approaches infinity, xn plus 1 minus xn is come to be the c, where the sequence of the real number, c is my positive real number. Okay, can you choose any of the sequence? So clearly say that's a difference of them. If I choose, then what is my answer of this? So it will be n plus 1 minus n is c. So the answer of this is 1 is equal to c, fine. So now this c is a positive number, so it satisfies the condition. So what is my sequence? xn is my n, so n over n, this is 1. So sequence is my 1. So it is not a bounded wrong, because the constant sequence is always bounded sequence. Constant sequence is always the convergent sequence, but he said not convergent sequence. It converges to the 0, wrong option, because it has a 1 value, so it converges to the to 1. So this option is cancelled. It converges to the C. So what is the value of the C is? C is my 1. So yes, this is my right answer. Okay, Xn is the convergent sequence. Which of the following is the limit of the sequence? Always remember, whenever you have this form, Xn plus 1 is say something of this form, always apply the numerical methods. Although this is a question of the sequence and series, but always apply the numerical methods. What is the convergence condition? Convergence condition is phi dash of Xn should be less than of 1. So if you look about this, what is the phi is my here. So what is the phi dash? It is 1 is 0. It's a 1 over 2 times Xn minus pi. This is the tip number 1. What is the second tip is? Which of the following is the limit? So whenever you are talking about the limit, it means it is must be the fixed point. Fine. What is the meaning of the fixed point? If I substitute x as a pi plus 1 in this question, so is it satisfied? You can check about. It is pi plus 1 minus pi. So yes, it's satisfied. So it could be the answer. Second option is pi plus root 2 is pi plus pi will be cancelled out. It's a root 2 which is not same. So this option is cancelled. It's a pi is equal to pi plus pi minus pi. That could be the right answer. It could be 1 plus root pi, which is pi plus pi will be cancelled out. So it's a root pi which is not same. So these two options are cancelled out. Now out of these two options we can see which value should be less than of the 1. So firstly, at x is pi plus 1. If I substitute here, it is 1 over, it is 1. So which is less than 1. Satisfied? Yes, this is the right answer. If I check about at x is equal to pi, what is that? It's a 1 over 2 is a 0. That means infinity, which is not be less than 1. So this option is cancelled. A is my right answer of the problem. Always whenever you have a sequence of this nature, always apply the fixed point iteration method. Okay, f is my strictly increasing function. Strictly increasing means derivative should be greater than 0 and a continuous function. Can you choose any of the function whose derivative is strictly greater than 0 as well as continuous? A very simple example is f of x is x. An is a sequence of this. So an is a sequence in 0 to n. Then you have to check whether it's increasing, bounded and here. So an is the sequence belongs to the 0, 1. That's a closed interval. So what does it mean? F is my continuous. So what is my f of this? It is belongs to the f of 0, f of 1. So what is the meaning of that? It is my bounded always. Fine. Or you can also write like this way. A, whatever the sequence is there, it lies between 0 and 1, and because of this continuous function, I can say f of 0, f of an is less than f1. That means it is my bounded. So he said not necessary bounded. Bounded is the right answer. Now how you can discard the other option? You can consider any of the sequence in the 0 and 1. So say 1 over n. Then what is my f of an? 1 over n. Is it increasing? No, it's a decreasing sequence. So this cancel. Is it a convergent? So can you think about any of the example which is not a convergent? So that means limit is not same. If I consider this one, 1 here, is it lies between? No. This one. Fine. Is it true? Yes. Now what is the f of an? It is 1. I have considered the x. So what is the limit of this? Limit is it's a convergent. Can you provide the one counter example which is not a convergent? How you can prove that? Okay. If I simply choose the sequence is 1 plus minus 1 raised to power n, then what is the f of an is 1 plus, fine. Okay, if it is outside the 0 1, you can divide it by 2, there is no issue. Fine. So clearly say this is my not convergent. Fine. Because why? Because the limit is, sometime it is my, if it is n is even, it will be 1, and if it is odd, then it's a 0. So limit is not unique. So once the limit is not unique, it is not a convergent. So this option is also cancelled out. Right option is only B is the right answer. The sequence is convergent, monotonic, bounded. Convergent and monotonic. Very simple. Firstly, it's a minus cos half tan inverse. I can return this is minus 1 raised to power n separate, n over 2 raised to power n as a separate. Fine. So this value is either the positive or negative depending upon the even and odd. So if it is n is even, fine, if n is even, this value is my positive, then the term will be cos half tan inverse n over 2 raised to power n. And if n is my odd, it is a negative, it can be outside, but cos is always a positive term, so that's the same meaning. Now you can see this value, it is always an increasing because of the power n. So what is the maximum limit of this? It's infinity. So what is the tan inverse of infinity? It is pi over 2. So what is the cos pi by 4? 1 over 2, which is finite. So once is a finite, it means, that means if I take the limit as n approaches infinity, this value will be my infinity. So once this is a infinity, tan inverse infinity is here, which is a finite and unique. So what does it mean? It is my convergent. So it's not a convergent, cancel, not a convergent, cancel. Then how you can prove that it's a monotonic or not? Again, a very simple. You can see cos x is always the bounded function. Cos x, what is the maximum value of this? Is a pi by 4. So that means what is the graph of 0 to pi by 4? Pi by 4 is my cos graph will be my here. Fine. So what is the meaning of that? It is my decreasing function, or it's a monotonic function. So it's a monotonic and convergent both. That's a is my right answer. Fine. So the graph of the cos x will be here. So it's a monotonic function. Okay. The sequence Sn is given to be here. Sn. So I can return this is my summation of 1 over n plus 1 sine of pi over 2 raised to power n. Will n start from the 1 to here. Fine. Then the sequence convergent or divergent. So that means that's a simple. Okay. What is the tips for you? That means you have to check about the convergence of this series. Fine. How you can check that? If I take the limit as n approaches infinity, so this value will be my infinity. So that's my infinite series. Fine. How you can check the infinite series convergent? By using some test, by the ratio test, root test. So what is that? Remember, whenever you have the an into bn form, if you prove that one of the sequence is my bounded and the other one is my decreasing and goes to the 0, fine, then I think you got that. By using the Dirichlet test, the series is convergent. Fine. Now look at the same concept here. This series is my bounded, this is my decreasing, fine, and as n approaches infinity, it goes to the 0. It satisfies both the properties. So by the Dirichlet test, this series is my convergent. That means this is my convergent sequence. Fine. So it means Sn is my convergent, and now you can see they are working on the real line. So whenever on the real line, convergent implies Cauchy and Cauchy implies convergent. So yes, it's a Cauchy sequence. Rest options are cancelled. Okay, which of the following sequence is my convergent which lies on this? Again, very simple. Assume an convergent to the L. I can substitute here. It is 4 over L, 3 over L plus L cube over 81. So can you find the value of this? 1 over L L cube over 81. So L will be my 3. Fine, because you can see 81 is L raised to power 4. So 3 raised to power 4 is, so L is 3. So 3 does not lies in this, does not, only option 3 lies here is the right answer. Okay, Sn is a sequence of the positive real numbers satisfying this such that alpha is less than of S1 is less than of beta. Which of the following sequence are my true? Look at that, they are not talking about what is the value of alpha and beta. Alpha and beta are the roots of this, but we don't need them. Now, what is the tips for you? As we all know, if you prove that the sequence as xn is monotonically increasing, fine, then, and it is a bounded, Sn is a bounded, it is already given that, okay, we will prove that it's a bounded. If Sn is a increasing and bounded, then what does it mean? Sn is convergent to this upper limit. Fine. On the other hand, if you prove that Sn is my decreasing and the bounded, then this Sn will converge to the alpha. Fine. So now we will see that if this option is correct, then this option is correct. If this option is correct, increasing, then it converges to the beta. So how you can prove the increasing or decreasing nature? Very simple. So that means I can start from the Sn plus 1 minus Sn. Fine. So, or I can say 2 times Sn plus 1 minus of this. So it will be Sn square plus 3 over 4 minus 2Sn. So it has the root alpha and beta. So that means x minus alpha, because this is the same equation of this, and it has the root alpha and beta, it lies between this. Fine. Now S1 is lies in between them. S1 is lies in between them. So what is the value? If I choose any of the numbers, say alpha 1 is here, say this, I can choose any number in between them, say 1.5. So this number will be my negative, sorry, this number will be my positive, this number will be my negative. If you choose any number between alpha and beta, this number is the positive, this is negative, so it means this is my less than 0. So what does it mean? Sn plus 1, this is my decreasing sequence, and once it's a decreasing sequence, it converges to the alpha. So A and C are my right answer. You can see also that from the option they are not asking you to solve them, they are asking you about the conceptual. Okay, the least upper bound of the sequence. How you can find the least upper bound? That's very simple. I can check about the limit. My purpose is to check about the limit of this. But again, sin n pi by 2, it is sometime it is a 0, it sometime it's a 1. It's depending on the even and odd. So it means I need to check s of 2n, s of 2n plus 1. If I prove both converges to the same limit, then we can say the sequence is convergent, and then we can find. So if s is my 2n, that's even. When n is my even, when n is my even, this value will be my 0. So the answer is 0. When n is my odd, fine, that means n is my, say, 2k plus 1. So this number will, when n is odd, this number will be my minus 1. So then s of 2n plus 1 will be 1 over 2. This number will be my odd, so 2k plus 1, and this number will be my 1. Fine, because whenever n is odd, it will be my 1. So what is the limit? As n approaches infinity or k approaches infinity, it is my half. Fine. So what is the upper limit of this? It's a 0, it's a half. So the least upper bound will be my 0.5 is the right answer of this problem. Okay, look at this another one. The sequence of the real numbers. Okay, what I gave you the tips, whenever you are trying to find this, it converges to the L only if you find an plus 1 over an, it is L by the Cauchy second theorem. Fine. But if you see that this is my Sn, The best way is I can take the logarithm of this. So log of sk, it will be alpha over k log of k. Fine. Then what I can do is alpha log of k raised to power 1 over k, and we all knows what is the limit as n approaches infinity of n raised to power this, it is by 1. Fine. So if this value is my 1, log of 1 is 0, so it is 0. So log of sk is my 0. So what is the sk? It is my 1. So if this is my sk is my 1, so by using this ratio is also the 1. So if ratio is 1, so it is also my 1 is the right answer of this problem. Always apply the Cauchy's second theorem by using the logarithm property. Okay, so sequence convergent or not. Assume that this convergent to the L, Bn is convergent to the M. So by using this here, it will be L, it is root of Lm. So that means L square minus Lm is 0. So L is 0 or L is M. But 0 is not possible because it is strictly greater than 0. So that means L is equal to M. Or you can consider from the second one, it is M, L plus M over 2. So from again you can see L is equal to M. So that means both the sequence convergent and convergent to the same limit. Which of the following is not true? Fine. Now we will see whether it's a bounded. How you can prove that it's a convergent? It's a limit are same. Whether it's a convergent or not, now you can see. What is the meaning of that? An plus 1 is the geometric mean of An and Bn. So that means An should be less, because A1 is less than of the B1. So I can write here. Fine. Also from this, Bn plus 1 is the arithmetic mean of An and Bn. So I can say An Bn plus 1 is less than of this one, and we all know arithmetic mean is always be greater than of the geometric mean. That means Bn plus 1 is greater than of An plus 1. So I can start from here, A1 or An less than An plus 1 less than Bn plus 1 less than Bn. Fine, because Bn plus 1 is less than of this. So from here what you got, this is decreasing, this is increasing sequence. Fine. From here we can say this is my decreasing sequence, and the B1, so, and A1 is my greater than 0. So what does it mean? An is my increasing, An is increasing, that's a correct statement. Bn is decreasing, correct statement. Also it is a bounded. So once it's a bounded, it's a monotonic. So that means it's a monotonic, it's a bounded, that means it's a convergent. So it's a convergent and limits are same, and this option is wrong option. But he said which of the following is not correct statement. So all these three options are cancelled out. A is my correct answer of the problem. Okay. This is, I already told you many times. Look at that. This is my AP. Fine. So whenever you have the term of this, it is always about the common difference. What is the common difference of the AP is root 3. So 1 over root 3 is the right answer of the problem. Which of the following statement is my true? Every sequence has a convergent subsequence is a Cauchy. It means if I have a sequence An, it has a convergent subsequence. So it means convergent subsequence. An is my convergent subsequence. Fine. Then he said it is a Cauchy sequence. Okay. If I simply say An is my sequence which is 1, 0, n is say even, n is my odd. I can say the subsequence is even number which is 1. It is my subsequence and it's a constant sequence. So that means this is my convergent. So it's satisfied. Now you can see from here, is it a convergent? No, because limits are not same. So the sequence is not convergent, and we are talking on the real numbers. If it is not convergent, it implies it is not Cauchy. So the first option is cancelled. Every sequence has a convergent subsequence is a bounded sequence. Again, a very simple, I can simply choose 1 if n is, and n if n is odd. So clearly say, if I consider the subsequence again, 2n is a convergent and subsequence, but clearly say this is my not bounded sequence because of the presence of term n. So this option is also cancelled out. The sequence Sn has a convergent subsequence. Yes, it is a bounded sequence. Found. It is also the monotonic sequence. So once it's a monotonic and bounded, it means it has a convergent sequence. And if it is a convergent, yes, you can say it. And we all know every bounded sequence has a convergent subsequence. So yes, this option is correct. This has a convergent subsequence. Clearly say this n is my unbounded. Fine. So once this is unbounded, so what is the limit of the n approaches infinity? That means this is a divergent sequence. This is my divergent sequence. Once it has a divergent sequence, it can never have a convergent subsequence. So the right answer is A is the right answer. Okay, which of the following is this one true or not? Again, very simple. Xn converges to the 1. Again, Xn is my phi of Xn. Fine. So what is my phi is Xn cube plus 6 divided by 7. Firstly, we can see whether it will be convergent to the 1. 1 must be the fixed point. So I can substitute here. It will be 7 is 1 plus 6. Yes. Is it 2? 14 is 8 plus 16. Yes. 1 already checked that. Minus 21, which is minus 27 plus 6. Yes, it all are satisfied. Now x1 is my greater than 0. So it means whenever you have convergent to the L, and that L is must be greater than 0, but it is my minus 3. So this option is cancelled. Fine. Now look at this another one. X1 is half, which is less than 1. Fine. So if x1 is less than 1, what is the derivative of this? It is 3 over 7 x2 square. So the derivative of this will be 3 over 7, which is less than 1. Yes, this is a convergent. Fine. This is a convergent. Again, this is now it convergent to the 1 or 2. Again, the same tips I have given you. If any of the sequence is my convergent to this, and if you prove that Sn is my increasing, then it converges to the beta. If you prove that Sn is my decreasing, then it converges to the alpha. Fine. Now you can see xn plus 1 minus xn. I can start from this one. It's a 7 times. So it will be xn cube plus 6 minus 7xn. And you can see this is the same term of this. Now what are the roots of this? So clearly say 1, 2 and minus 1. 1, 2 and plus 3 are the roots of the equation because it's satisfied. So whenever x1 is half, this number is negative, this number is negative, this number is positive. So that means this is greater than 0. So once it's an increasing sequence, it converges to the upper bound. So what is the upper bound of this sequence? I already proved that if x is less than 1, x cube is also less than 1. I add 6 on the both side, it is 7. If I divide it by 7, it is less than of 1. So the upper bound is my 1. So that means the first option is correct, second option is cancelled. Now look at the another option. Whenever x1 is 3 by 2, whenever x1 is 3 by 2, this number is my positive. 3 by 2 means 1.5. Fine. this number is negative, this number is positive. So it means this is a decreasing sequence. Fine. So whenever x1 is a 3 over 2 which is greater than 1, whenever x1 is greater than 1, x cube is greater than 1, I add 6 on the both side and then divided by 7, it must be greater than of 1. So that means it is 1 is less than of xn plus 1 is less than of something. So whenever it's a decreasing sequence, it converges to the alpha, and alpha is my 1. So yes, this is also the correct answer of this problem. Okay, an is my here, then the limit of the an. Okay, I think you must remember that, or you must know about what come in your mind when you think about this. That is a recurrence relation. Fine. Once you know the recurrence relation, how you can write the equation? That is the m2 is m plus n plus 0. So this is m raised to power 0 and m raised to power 1. So what is the answer of this? M square minus m minus 1 is 0. So can you find the value of this? M plus minus root 5 over 2. So but you can see the first number is my positive, b1 is my positive, so it must be converges to the 5. So that's the answer of this problem. Okay, look at this another one. Sn is given to be here. Which of the following is my true for the sequence Sn? If you look about here, what is the Sn limit convergent of there? Fine. So what is the meaning of that? It is 1 over 1 factorial, 1 over 2 factorial, and up to the infinite. What is that? This is the e raised to power 1. So that means the sequence is convergent to the e. Now look at the option. Is e is in the r, but he said q. If it is r, it's a convergent. So convergent implies Cauchy. Yes, it's a Cauchy sequence, but does not converge in the q. Yes. The subsequence xn converges to the, okay, it's a constant sequence. Fine. So whatever the subsequence you can consider, it also converges to the e. Fine, for all the values of the k, but you can see he said only. So that's the wrong option. This is not a Cauchy sequence cross because it's a convergent, and in the R every Cauchy implies convergent. Okay, which of the following is a limit supremum infimum are here? Again a very simple. Look at that. If I take n is my even, firstly, it's very simple. Fine. So then your an will be, I can say n is my 2k. So it is my 2 raised to power 2k means 4 raised to power k, where k very strong, 1, 2 and so on. So clearly say this is my, is it increasing or decreasing? It's a decreasing sequence. So once it's a decreasing sequence, can you find the infimum and the supremum? Again very simple. Once it's a decreasing sequence, you can find the infimum as the upper value is a infinity. What is the infinity? Answer is 1. Whenever it's a decreasing sequence, the supremum will be found by the lower value. It's a 5 over 4. Now whenever n is odd, this number is either the positive, because if I take n is my 5, then this number will be my n minus 1 minus 1 of this is my positive. But if I take n is my 11, then it will be my minus 1. So I have the two cases. Whether now for this here, when n is odd, so you have the two cases. That means n minus 1 over 2, it may be the even number or it may be odd number. Fine. So if I consider this is my first case is say 2k, that's even. So n will be 4k plus 1. Then whenever n minus 1 over 2 is my even, so this number is my positive. So my sequence will be 2 plus 1 over 4k plus 1. So what is my k is? So it's an even number, so it is start from the 0, 1, 2 and so on. Now again clearly say this is my decreasing sequence. So once it's a decreasing sequence, you can find the infimum and the supremum. So what is the infimum? Because it's a decreasing, as I told you earlier, it's an infinity. So it will be, when it's infinity, it's a 2. And what is the supremum? When you substitute the lower limit, it's my 2 plus 1 is 3. Now when it's an odd number, you can say it's a 2k plus 1, so then it will be the 4k plus 1, and then it will be 4k plus 3. Fine. Then this number will be my minus of 1, so this is my 2 minus 1 over 4k plus 3, and you can see this is my increasing sequence. So once this is my increasing sequence, you can find the infimum and the supremum. What is the value of the k is 0, 1, 2 and so on. So now you can reverse them. How you can find the infimum? In the decreasing case, at the infinity. Now the supremum value I can find at the infinity. What is the infimum value? At the starting point. So whenever k is 0, it is a 6 minus 1, 5 over 3. Fine. Now you have found all the infimum and the supremum in all the cases. So what is your right options? You can check about the options. What is the supremum of these cases? Firstly, supremum 5 by 4, 2. So supremum is my 3 is my supremum. What is the infimum? 1, 2 and 1.5. So infimum is my 1. So infimum is 1 for all n. Supremum is my 3, correct option. Infimum and supremum both are same. This is 3 and 2. This is, so A is my right answer of this problem. Always firstly simplify your sequence and then you can get your answers. Okay, your target is to find the sequence limit of this. Okay, if you look about this sequence S1 plus S2 Sn over n, if you think about, can you apply the Cauchy first theorem? No, because Cauchy first theorem is applicable only on the positive term series. Fine. Can you check about whether each of the Si are my greater than 0? Each of the SIs are depending upon the AIs, and AI may be positive or negative. It means you can never apply the Cauchy first theorem. Fine. So whenever you are unable to apply the Cauchy first theorem, what is the definition of this? I can choose n is my even. Second is when n is my odd. Fine. And if I found both the cases limits are my same and unique, then we can say the limit is convergent. So when n is even, that means sigma of 2n. So it will be sigma of, it is my 2n. So it is S1 plus S2 plus S2n. And when it is odd, then 2n plus 1 will be 2n plus 1, S1, S2 and S of 2n plus 1. So what is the Sn? You can see when you take A1, what is the A1 is? It's an alternating series. Okay, so definitely it is a 0 when your n is even. Fine. It's clearly say it's a even when it's a 0. And what will happen for the odd? It is my 1. Fine. Now you can substitute here. What is that? When it is a even, for all the terms up to the even, it's a 0 over 2n. It is my 0. Fine. Now, sorry. It involve also as the even terms, also involve as the odd terms. How many even terms involved? Out of the 2n, how many terms are odd and how many terms are even? So 1 plus 1 plus 1, that's a n. Fine. So the right answer is half. Now look at that. What is the S1? S1 is odd, it's a 1. S2 will be 0, S3 will be here. So what is the right answer of this? It will be 1 plus 0 plus plus up to 1. How many terms are there? It will be n plus 1 terms. So 2n plus 1. What is the limit of this as n approaches infinity? So in both the cases the limits are my same. So therefore it's a convergent sequence. So if it is convergent, then it converges to the half is the right answer. Fine. Always remember Cauchy first theorem is not applicable. So we can discretize into the even and odd. If, always remember, if the limits are my say different, then what is the meaning of that? Sequence is divergent. Fine. Then you are unable to find this sequence. An is a sequence of this. Which of the following statements are my true about the subsequence? a of 6n minus 1, a of 6n plus 4. So I can found it's a of 6n plus 1 firstly. So sine of n is my this, pi over 3. So it will be 2n pi minus pi over 3. Fine. What is the sine of 2n minus is a minus sine pi over 3, and what is the cos of 2n minus is cos pi over 3. So what is that? Is a maximum of is a 60 degree. What is the cos 60 degree? It's a sine 60 degree minus root 3 over 2, and it is plus 1 over. So the maximum is half. What is the a 6n plus 4? So if it is a 6n plus 4 over 3 into pi. So if I open this, it's a 2n pi plus 4 pi over 3. So it will be the maximum of, what is the sine of, it lies in the first quadrant. So it's a sine of 4 pi by 3 and cos of 4 pi over 3. So again, what is the, I can break this component as pi plus pi over 3. So it will be maximum of minus sine pi over 3 and minus cos of pi over 3, because it lies in the third quadrant. So what is the answer of this? It will be minus root 3 over 2. It is minus 1 over 2. So what is the right answer of this is minus 1 over 2 is the maximum. So both the subsequences are convergent, yes, fine, because they are converges to the finite and the unique limit. So both these subsequences are convergent. Only one of the subsequences is convergent. An is convergent, 6n convergent to the plus 1 by 2, but he said minus 1 by 2. A of 6n plus 4 is convergent to the plus 1 by 2, but convergent to the minus 1 over 4, 2. So the right answer is only A is the correct answer. Okay, which of the following is my here? So clearly say what I told you, this is an plus 1 is phi of an. So what is my phi? This is an plus an square. Then your target is to find the limits. Limit means convergent. What is the phi dash of an? 1 plus 2 of an. Now clearly say a1 is my increasing, is a positive number. So this number will definitely be greater than 1, because this number is my positive. Fine. So what is given to you? Whenever phi dash of x is less than 1, then we get as a convergent, otherwise divergent. So what does it mean? This an is my divergent sequence. Fine. So once it's a divergent sequence, limit will not be 0. Once it's a divergent sequence, 1 over this is not be 1, or you can see 1 over an will goes to the 0. What is the divergent sequence means? That is the an will goes to the infinity. So 1 over an will goes to the 0 as n approaches infinity. So 1 over is 1 is the wrong option. Now look at the first option. We need a A4. Fine. So firstly A1 is given to you. What is my A2? A2 will be A1 plus A1 square. That means A1 1 plus A1. What is my A3? A2 plus A2 square. That is A2 is common, 1 plus A2. What is the A4? A3 plus A3 square. So A3 is a common, 1 plus A3. Now can you make them? I need a A1, so I can substitute the value of the A3. I need a 1 plus A3 also, so I can substitute only at this side. 1 plus A3. I can substitute the value of the A2 as here, and you can see this is the correct answer of the problem. Okay, look at that 2020. Sn is my here. The sequence Sn is convergent or not. Limit n approaches infinity of Sn. 1 plus. Fine. So clearly say this number is my bounded, and this number will goes to the 0. So this number will be goes to the 1. So yes, this is my convergent. So it's a convergent to the 1, convergent to 1, convergent, it's a divergent, option cancel. Now it's a monotonic increasing or decreasing. So we all know this number is neither monotonic increasing nor monotonic decreasing, because sometime it's a 1, fine. If n is equal to 1, it's a minus 1, fine. If n is equal to 2, it's a 1 over 2, then minus 1 over 3, then 1 over 4. You can see this is not increasing or decreasing. So it means is increasing, cancel, decreasing, cancel, neither increasing nor decreasing but convergent to the 1 is the right answer. Okay, sequence of the positive real number is given such that L is my here. Which of the following sequence is my correct? Firstly, I can give you the tips. We all know whenever an plus 1 over an as n approaches is say L, then limit an will be 0 if L will be less than 1, it goes to the infinity if L will be greater than 1, fine. So if you look about this shortcut tricks, the first answer L is less than 1 goes to the 1, wrong, because it must goes to the 0. Now what will happen at the equality? So we can't say anything, so I can simply choose the one counter example, fine, because it's a positive sequence. I can here, what is the an plus 1 over an? It's a n plus 1 over 1, so it will be 1. So that means L, what is the value of the L? L is my 1, fine. So if L is 1, the limit of an, what is the limit of an? It's infinity, but he said 1, he said 0, so that's a right answer of the problem. Okay, monotonically increasing limits are there, so I assume this limit is my L, then this value will be L square is 1 plus L square over 1 plus alpha, so I can multiply them. L square plus alpha L square is 1 plus L square, so L square will be, so this is, it means L is convergent to 1 by root alpha. So the sequence is convergent to 1 by root alpha, so this option is cancel out, this option is cancel. Now it's a monotonic increasing, it's a monotonic increasing, so there is no need to check whether it's increasing or decreasing, fine. Otherwise you can also check from here whether it's increasing or decreasing. So if you check that, it comes to be increasing, so definitely this option and this option cancel out. Now look at that. Now if this condition hold, it means if Sn square is less than of 1 by alpha, then now it is a monotonic. We only need to prove it is a bounded. If I prove that it's a bounded, then it's a convergent, fine. Then Sn square, I can add 1 on the both side, it will be alpha plus 1 over alpha, then I can divide it by alpha plus 1, it is my here, fine. And if I take the square root, it will be Sn plus 1 and it is my here. So clearly say Sn plus 1 is my increasing and it is bounded above, fine. So what does it mean? If it is increasing, as I told you in my previous shortcut tricks, whenever you have here, if it is increasing, then it converges to the upper bound, and upper bound is my here, so that means limit of the Sn is my 1 over alpha, so that's the correct option. On the other hand, if he said it's a greater than, so what does it mean? It means it is a my greater than, this is my greater than, this is my greater than, and this is my greater than. So this is my basically here. So for that we need a decreasing sequence, but it is an increasing sequence, so that's why the only option A is my correct answer. Or if you want to prove how you can increase or decrease, this is the first method. If you want to prove that it's increasing or decreasing, how you can prove that? Again, I can start from the Sn plus 1 square minus Sn square, fine. So it is 1 plus Sn square over 1 plus minus of this. So if I take the LCM, fine, 1 Sn will be cancelled out, so 1 minus alpha Sn square. So since alpha is my positive, this number is my positive, and whenever Sn square is less than of this, what does it means? This number is greater than 0. Fine. So whenever this number is greater than 0, what does it means? Sn plus 1 should be greater than Sn. That is a increasing sequence. Okay, look at this one. Which of the following is the relation? Again, it's a limit. Fine. So can I say always express in this form? Denominator is n square and the numerator is my k. K start from the 1 to n minus 1. Fine. So again I can take k is my this one. So this is 1 over x. Whenever n is 1, limit is 0. Whenever is n minus 1 over this and n approaches infinity is a 1. So the answer is half. So therefore a is my 1 over 2. Look at this another one. How you can write this? It's a limit n approaches infinity is a summation of k over n plus k. I can divide it by n. It's a k over n and it's a 1 plus k over n. Then I can put this as a k, x. So it will be x over 1 plus x. No, sorry, it's a 1 1 1. It's not a k. It's a 1 1 1. So it's a 1 1 1. So it's a 1 only. Fine. So limits are when what is the lower limit is 1, upper limit is my n. So it's my 0 to 1. So it will be log of 1 plus x from 0 to 1. Options are ln 2. So I can written as ln. Fine. So this is my ln 2. So what is that? A is my half, B is my ln 2. So clearly say this ratio will be cancelled out. Product of them, yes, you can see it will be half ln 2, which is ln of root 2. A is my 0.5. What is the ln 2 is? 0.3 something. So A must be greater than of B is the right answer. Okay, look at this one. Okay, limit of yn. Yn is my here. So it is 1 minus limit of xn. Fine. So what is the limit of this value? It always goes to the 1. So this value is 1. So 1 minus 1 is 0. The right answer is 1 is the correct answer. This is the same question as I explained you earlier. So it's a AP and I can say y1 is less than of the x1. So you will get as yn is less than of xn. This is my GP. Okay, geometric mean. This is the arithmetic mean. So geometric mean is less than of arithmetic mean and xn plus 1 is less than of xn and this is my yn. Fine. Now clearly say from here y is my decreasing, sorry, y is my increasing. Fine. And this is my decreasing. So xn is my, okay, and it is also given as a, this number is x1 is a 1 and this number is half. So clearly say it's a bounded, it's a monotonic, so that means it is a convergent. So yn is not convergent, this is cancelled out. Now if they are convergent, then I can find the limits. If I say xn is L, so L plus m over 2, so that means L is equal to m. So that's a D is the right answer, C will be cancelled. Okay, this is convergent, convergent, an is convergent, convergent are they. Again, limit n approaches of this. Can you find the limit of this? This is the E. Fine. So which is a finite and unique. So what does it mean? This means this is my convergent. B cancel, D cancel. This one is a bounded or not? This number is bounded. Fine. But this n is my unbounded. What is the meaning of that? This number is my Bn is unbounded. So Bn is unbounded, Bn is unbounded, An is convergent. Yes, sorry, this is the bounded. So this option is cancelled. C is my right answer. Okay, look at this one. An is a sequence of the real numbers such that here. So clearly say what is the limit of n approaches of an, which is either the 1 or -1. So it's a not unique. So what does it mean? Sequence is not convergent. Fine. So both an is convergent, cancel. An is convergent, cancel. Fine. Bn both are. Now what is the bn? So what is the bn? An over n. So it's a 1 over n minus 1 over n. What is the limit as n approaches infinity? 0, which is unique. Once is a unique, it means this is my convergent. So bn is convergent, but d is not. Look at the last question. So this is the same shortcut tricks as I told you in the earlier. An plus 1 minus an if it is form of the Cn and Cn is convergent, then you can say this sequence is convergent. Fine. So if you compare them, for the first case is 1 over 2 raised to power n. So summation of the Cn is 1 over 2 raised to power n, which is the GP series, and the common ratio is my half, which is less than 1. So it is a convergent. So what does it mean? This is my convergent. So, and if it is a convergent, then it means it's a Cauchy as well, because on the real line Cauchy and the convergent are the same. An need not be Cauchy, cancel out. Both need not be Cauchy, cancel out. For this case, your Cn will be 1 by root n. So what is the series of the Cn? Series is 1 over n raised to power half, which is a divergent by the p-test. So that means this bn need not be convergent. So if it need not be convergent, it means need not be Cauchy. So bn need not be Cauchy, and A option is cancelled. I hope you can simply learn this. We will see the next lecture on the infinite series. Till then, you can simply like, share and comment on my video. Best of luck, students. Happy learning.